Hey guys, how's everything going? This is JSer, who is not good at algorithms. In this video, I'm going to take a look at number 380, insert, delete, get random 01. We need to design a data structure that supports all of the following operations in average constant time. So insert an item val to see if it's not already present. Okay, so yeah, let's first look through the descriptions. Remove one. Remove an item from the set if it's present. And GetRandom returns a random element from the current set of elements. Each element must have the same probability of being returned. Well, for the first two, like if we were using a set, we could actually set insert is constant, right? And then remove, it's constant. Okay. But get random, we cannot get random because set actually, like it's a hash table. The key of the val is hashed into the pointer, I don't know, in the memory. So for get random, we cannot do this. Is there any other way to do it? Yeah, if for storing numbers rather than use set without order, we could use array. Actually, if we use array, we can get random, right? This is very good. This is just we get the length of the array and then get the random index and get that element out. Well, so get random we could achieve by 01 insert. Well, we actually don't care about the order, right? So we insert it, we push on the push at the rare, so it's actually still 01. But here's a problem: remove. Say we have an array of 1, 2, 3, and we need to remove a number in the middle. Then the items after that item, all those items after that number, we must be shifted to the previous one, right? We should just be moved backward a little. So that's actually has a lot of work to do, and that's not constant time. As for the worst case, well, it'd be linear time. So we see that we could use set to achieve two of them, and use array to achieve two of them. So how we could do? Well, because we're going to get random, so array must be used, right? And so the only problem is that how we can make some polyfills or try to find a way to make the removal to constant time. Okay, so idea, use array, but try to improve removal to constant time. Well, as we already see that your set could do the remove with constant time. Let's see how can we use another extra set. Well, if you use only one array, obviously we cannot accomplish this. We need to use extra data structure, and we use extra set to help. So how we do this? Let's first analyze E1, 2, 3, 4. If you're gonna remove 2, how could you do it? Well, suppose like we are removed 2. Now first we need to find where 2 is, right? If you're gonna okay, first we're not gonna find where 2 is. That actually costs us linear time. So the first we should use set to store the index. So it's a set num index, and then if we want to delete 2, we could get the index from the set. And then what do we do? If we just use splice in JavaScript, it will cause 3, 4 to move moving backward, right? So that's not optimal. Here's the idea. Because we use this array, but we don't actually care about the order. We are going to use to create a randomized set. The order doesn't matter. Here's a trick, because if we do push and pop is actually constant, when we remove, we actually could swap this element to the final element and pop it from there, right? Swap node to the bottom with the where pop at 01. So in total, this action will be still in constant time. Okay, let's do it. Well, we could set these nums, empty array, and this indexes. Not set, man. It's a map. I made a mistake. Map. We use map. Set it to yeah. It's empty. Cool. Now, when we're insert, what do? We say we get the index, right? Index equals this nums.end and this nums push val, this, and then this indexes set val index. Cool. And now we need to remove, right? Remove, as we said, you first get the index, and then swap. Okay, we use this spread. It's not that, not spread. It's this destructuring. It's not that concise. I'll use say swap. This is right? Okay, I can make this shorter, like const nums. Okay, length. And then pop it, right? So now we remove it. But there's another thing we forgot, is that we need to update the index, right? So for val, the index is for val, we should remove the indexes. Delete val, and the last number, which is this one. Okay. Update the index there. Yeah, so the remove is done, and now get random. Well, we have this nums array. Suppose there's 3 numbers. These actually, the index will be from 0 to 3, but 3 is not included, so we should choose the floor. Yeah. Cool, I think we're okay. Let's try to run the code. No, before we submit the code, we try to review our code once more. We use a num, use a map to keep track of the indexes. When we insert, we push the array and then set update the index. It's cool. And now when we remove, we first get the index and then swap to the last number. And then pop the last one, right? And then we delete this item in the map from the map and update the index for last one. And when we get random, we first choose a random index with an n and return it. It should work. Ah, no. Runtime error. What? Map. Uh-oh. Yeah, we need a new here. What? Uh-oh. We got some problem. Ah, I see. When there is already a number there, we should ignore it. Oh shit. I see. So these indexes, val, if has it, we just return to nothing, right? It's not about this. We insert 1, remove 2. There, the number might not exist. Still not right. What the? Okay, insert 1. Now remove 2. Insert 2. Get random. Undefined. What? What need to return? Returns true, he says. False. I didn't care about the return value. So here, return true. Return true. Return true. We get random. Yeah. There's some problem. The numbers is return right, but there's a case for insert. When there is someone already there, we need to return false. Yeah, okay, I forgot to issue false here. What? Last one is insert 2. False. We remove it. When we remove a val, the index is delete val. So when we get oh my god. Oh my god. So stupid. Cool. Finally we get it right. Still not right? What? Really? Okay. When we remove 0, it should be returned false, right? Yeah, return false. Return 0, false. Insert 0, we got true. And get random, we get 0. And then remove 0, we got true. And then insert. So index should be this index should be undefined. Insert. We delete it. Really? This, allow me to log the first one is when we insert it's empty, and then insert 0. So the delete doesn't work. I know what happened. So when we are removed there, if there is only one element, this actually swapping has a problem, right? Last number actually is the same, so we set to the same. We pop it. This works well, and actually, there's an order problem here. Ugh. Sad. Yeah, there's an order problem. God. Okay, finally we got it. So, well, that's all for this problem. Hope it helps. Even for this easiest problem, we should take extra care when we are thinking about swapping an elements. We should pay attention to whether they're at the same index. You see, this, yeah, it's very subtle problem. Okay, hope it helps, man. Guys, see you next time. Bye bye.